This is the AP Physics 1 Mass Practicum test corrections. Also, a little disclaimer, I apologize if I keep clearing my throat. I've been in and out of a cold for a little bit. So, as you can see, I already have a few things drawn out. I have the diagram of the practicum itself. I have my givens, which I won't really be mentioning until the very end, and I've already drawn out the free body diagrams for each of the three masses. So, first of all, for mass 1 and 3, it's pretty simple because all you really have is force gravity pushing down, and then you have force tension pulling the mass up since it's suspended. But the only difference being that for mass 1, it's being held up by rope 1. So I'll be referring to that as tension 1. And for mass 3, it's being suspended using rope 2. So I'll mostly be referring to that as tension 2. So we're just going to go through each of the masses, and we're going to first algebraically solve for each of the variables we need in order to solve the problem. So starting with mass 1, there's nothing in the x directions, but in the y directions we have force tension going up and then force gravity going down. So we have the sum of the forces in the y for mass 1 equals ma, and that is going to be equal to force tension 1 minus m1g, since gravity is acting in the opposite direction of force tension. And since it's in equilibrium, it's going to equal 0. So just to isolate force tension, we would have force tension 1 equals m1g. So that's pretty simple there. And then we have mass 2 next. And we'll have to do the x separately and the y separately since there are variables for both axes. And as you can see in my diagram, this is just to help myself remember things, but I've labeled the sine and the cosine so that I remember which one I'm supposed to use respectively for either the x or the y. So I'm going to start with the x direction. So the sum of the forces for the x of m2 is equal to, and so we have force tension 2 cosine theta 2 minus force tension 1 cosine theta 1. And again, equilibrium. So that's 0. And we want just force tension 2 by itself. So force tension 2 cosine theta 2 equals force tension 1 cosine theta 1. And then we'll have to divide we have to divide both sides by cosine theta 2. So force tension 2 equals, and also for force tension 1, we already know what force tension 1 is. It's equal to M1G, so we can replace that with M1G. So force tension 2 equals M1G cosine theta 1 divided by cosine theta 2. And now we do the y direction, and since we have force gravity acting on the mass in the y direction, which is mg, we will use this to isolate the mass of mass 2. So sum of the forces in the y direction for mass 2 is going to be equal to force tension 1 sine theta plus force tension 2 sine, I forgot to label this. This is sine theta 1 plus force tension 2 sine theta 2 minus m2g equals 0. And we have the same process of getting certain variables to one side just to get specific variables. So ft1 sine theta 1 plus ft2 sine theta 2 is equal to m2g. We can then, to get m2 by itself, we will divide both sides by g, but also we could substitute our variables for force tension 1 as well as force tension 2. So after that, we would have m1g, I'll put that in parentheses, sine theta 1 plus, for force tension 2, we have m1g cosine theta 1 over cosine theta 2 times sine theta 2 equals m2. So now we've algebraically solved for mass 2, and now all we need to do is use letters to solve for mass 3. So same thing, it's only going to be in the y direction since there's nothing going on in the x direction. So sum of the forces in the y of mass 3 is equal to force tension 2 minus m3g, which is gravity, equals 0. And so ft2, force tension 2, equals m3g. Now we could put m1g cosine theta 1 over cosine theta 2 is equal to m3g. But we need to be able to divide g on both sides. An easier way for me to think about it is when you divide, you're also just multiplying by the reciprocal. So we're going to multiply 1 over g here and 1 over g there. So g will cancel there, and g will also cancel there. So we actually have m3 is equal to m1 cosine theta 1 divided by cosine theta 2. I have already plugged this in with the givens listed into the calculator to find the masses of M2 and M3. So for my final solutions, M2 is equal to 0.273 kilograms, and M3 is equal to 0.245